Hello and welcome to this .NET Nugget session. It's one in a series of short sessions where we spend 10 minutes or so looking at how we can do things with Visual Studio and the .NET Framework. My name is Mike Talty and I work in the Developer and Platform Group at Microsoft in the UK. And this is a series of sessions about the Windows Communication Foundation, which is part of WinFX. And it's technology for building distributed applications. And in this particular session I want to take a quick look at how we can make use of session support within the Communication Foundation. And sessions are really a way of relating a set of messages to each other. So rather than just having a client and a service sending disparate messages that seem to have no kind of logical link to them, a session is a way we can group a bunch of messages together and know that they are in some way related. In particular, they came from the same place. We're here in Visual Studio 2005 and I'm using the WinFX September preview. And I've built two simple applications. One is a console application, and all I've done is gone ahead and defined myself my service contract, and you can see it just prints messages, and I've implemented that. And in the implementation all we do is we choose a random console color, and then we write the message to the console, and then we reset the console's color. Simple as that. And we've used what really by now is a standard service hosting code just to host that inside my application. My service to be available on HTTP, and I'm using this WS dual HTTP binding, which means that we're doing the advanced web services stuff, and we're sending HTTP traffic from the client to the service, but also possibly from the service to the client. So we've got two-way duplex communication going on over HTTP. And you can see if we look in the client's configuration, that again we've specified that binding. We've also specified the address at which the client will listen for any messages that come back to it over HTTP. So the Windows Forms application lets me type in a message. There's two buttons, one of which will create a new proxy instance and the second one will send the message. So clearly what we've got in our class is a private member that represents the proxy. This button creates a new one of those. This button uses it to send the message across to the service. I run my service and just get that console on the screen. Run my client, and clearly I can type in a message here. I can create the proxy and I can send, and it gets across to the service, and that's just what we'd expect. Now as I'm doing this, if I was sending a second message here on the same proxy and a third message and so on and so forth, the behavior that I originally wanted to program was that all the messages from one of these particular clients would appear in the same color. What I could do is I could change this interface so that we perhaps had an initial operation. Let's call this something like initialize color. And the client would call this operation first. I would pass them back some kind of token that represented their color choice, or the choice I've made for them. And then when they called me back, they would always pass me that token, and I would use that to index into my array of colors and print their message in the color that represented them. I would also have to have some kind of terminate color call, which took a token of some sort again, and that would tell me that I'd finished speaking to that particular client and I could reuse that color for somebody else. So this is fairly standard stuff. But it turns out with the WCF that I don't necessarily need to go down this route. This support is really already present in the framework. So what I can do is, let's forget these kinds of alterations, and let's forget this alteration here. I can visit my service contract and switch on sessions. And at this point, let's just see what happens. So all we'll do for a minute is just rebuild and rerun and have a quick look at messages trace just to see what the messages look like that flow backwards and forwards, just because of switching this guy on here. So I'm going to run up my service, create the proxy, send a message across. And let's just go and take a look at the messages that have been traced by doing this. Okay, so let's have a look at these trace messages. And you'll notice we've perhaps got fonts that are a little bit too large here. You'll notice that what we're getting set up between client and service is using this protocol called reliable messaging to set up a sequence of messages. So you can see the first thing that goes across is a request to create a sequence where acknowledgements should be sent to and so on. And you can see that address on the client being picked up with a magic GUID stick on the end of it. And Once that sequence is set up between client and service, the client then starts sending messages to the service with a message number on them. So you can see that this is message number 1, and the service will then reply back to them and say that it got that, and so on and so forth. So as we send messages from the client to the service, we will start to see them going up in sequence number on a session essentially that has been established between that client and the service. So there's now some contextual information flowing about this exchange of messages. And we can examine this a little bit more. Revisit our service code. Let's just have a look in here. One of the interesting things we can pick up as part of our operation once we switched on sessions is we can pick up a session identifier. So I'm just going to get my session identifier. We get it from our helper, which is the operation context. He has a current instance, and on there is a session identifier. So we can write out in here, let's put session ID, let's put some brackets on there, and we'll put that out as well. And so if we rebuild and rerun, let's run from here. Get our service up and listening. Get our client up and listening. As we create the proxy and send across, notice that we're subject to the vagaries of random colors here. But we get a session ID with a big GUID on it, and as we send again, we're on the same session ID, and again, and again, and again. So now we can start to identify messages from this client because we know that it's on a particular session ID. If we created a new proxy here and sent again, notice that we're now on a different session ID, and we'll stay that way until we create a proxy again. So it's a way of identifying a sequence of messages from the client. Now we're not making any statements about ordering of these messages or reliable delivery of these messages. We're just saying that we get a sequence of these things from the client, and we can identify that they effectively are part of the same conversation, if you like. In my particular made-up circumstance, of course I could use this to maintain some state. Let's just shut this down. On the service side, and I could track which color to use for a particular client. So I'll just throw in some code here to do that. Here is just keep a static dictionary. We'll go from a string to a console color, and we'll call that color map. Just create one of those, and then all we'll do is look up the particular session in that map, so if we're not already in there, what we'll do is we'll add a random color in there. Set the color now of the console comes straight out of that color map for us. And we'll worry later on about how we actually take those things away. In place, as we run our service and our client, so here comes our service, and we bring up our client. Let's create a proxy and send. Then we're going to use red now for that client until the session identifier changes, which we can do by forcing a new proxy here, and now we're using pink. And if we do that again, now we're using blue. So we've managed to set up a context essentially around the messages that flow from this client to this service, and we're just doing that based on those session identifiers. A number of other things we can do with session and the WCF. On a contract, what we can do is we can mark up operations. So let's add an extra operation here called begin conversation, and let's add a second one called end conversation. And we can mark these methods with our operation contract, and we can say that this one is an initiating operation. What that means is that you can call this method at the start of a new session with the service. As it happens, you can also call it partway through the conversation with the service as well. Now we can say on this method here that this is not an initiating operation. What that means is that if your first interaction with this service comes through this operation, you're going to get an error from the service. And if you think about it, having seen those message sequence numbers that we're tracking, essentially perhaps the way that this works is that the WCF can check to see if the message sequence number is 1, and if it is when you call this method, then you're out of sequence and you shouldn't have called this method straight away. And then finally what we can do here is on this operation we can say that this is a terminating operation. What that means is that when this operation completes, the session should be torn down, and obviously next time around you're back into a new session. We'll implement these on our class. So what we'll have here is just the begin conversation. And what we'll do is essentially pull out that session ID here, and we will go and add that to our color map as we were keeping before. Except we don't need to check if it already exists this time around, because we should be getting a new session ID here. Let's just put that code into the right function and that'll work a whole lot better. We can also implement our end conversation, and essentially what we're going to do at that point is once again get the session ID, and we'll remove that from our color map because the conversation's over. And then finally, in our print message becomes a little bit simpler than it did before. We can remove these pieces and just go straight into the color map looking for the session ID and print the color that way. Ahead and updated my proxy, and I've updated my client so that the client now has 4 buttons rather than 2 buttons. We have the new proxy, begin conversation, end conversation, and send, and these are just absolutely wired up to the things you would expect on the proxy in the background, and send is the same as it was before. Let's go and test that out by running. We'll get our service on the screen. We'll go ahead and get our client on the screen. Let's create the proxy. Firstly, let's try something bad. Let's send an out-of-sequence message. So if we jump straight into send, that's not the start of a session or a conversation. What it should find is that we get a failure from that. We just bring the client back to life because we just caused it to get an unhandled exception. And just have that client and service on the screen at the same time again. Let's create the proxy. Let's begin the communication. We'll send. We get blue. We stop. And that's the end of the conversation, and the communication between us and the service is torn down. If we make a new proxy, begin the communication, send, 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 end, and once again we're torn down. So we've managed to build that on top of the session support that's just built into the WCF. One last quick thing before we finish up here. This session support that we've just covered very briefly here is also the basis for some of the instancing. So when I say instancing, what I mean is that as messages arrive at your WCF service through the service host, it has a number of choices as to how many and how frequently it creates your implementation type. And what we'll do is cover that in another one of these nugget sessions, but it's very much linked to this, this session mode that we've switched on here in this session. So just to summarize what we've seen that session support's built into the WCF, and we saw how we could use it. We saw through the message tracing how the reliable messaging protocol was setting this up with a sequence of messages from A to B. We saw that we could have those is initiating and is terminating properties on our attributes that would control how long the session lasted. And finally, we specified that it is related to the instancing of your service types, and we'll come back and look at that in a second session. Okay, where would you go if you wanted to get some more information on the Windows Communication Foundation? Well, the best place to start is up at msdn.microsoft.com/winfx. And if you want to find some more information about the protocols, the web service open standard protocols that the Communication Foundation is capable of using, a good place to go for that would be msdn.microsoft.com/webservices. And that particular link we have on the slide here, /understanding, there's a great document there that specifies how all these things fit together to make a distribution platform as opposed to just a random set of specifications. And finally, if you want to follow up with anything you saw in this little session, feel free to drop me an email. My address is there on the screen. It's just mtolty@microsoft.com. Other than that, thanks very much for listening, and I hope to catch you next time.